Welcome back. This is going to be the final exam review part one, question number 4. And this is again another one dealing with volume. A manufacturer is designing a new container for their chocolate covered almonds. The original container was a cylinder with a height of 18 centimeters and a diameter of 14 centimeters. The new container can be modeled by a rectangular prism with a square base and can still contain the same amount of chocolate covered almonds. So if the new container's height is 16 centimeters, determine and state to the nearest tenth of a centimeter the side length of a new container if both containers contain the same amount of almonds. Now, let's be very clear. There's going to be gaps in between, and so we're going to just take it to heart that the same number of almonds means the same volume. And so we're going to find the volume of the cylinder first, and our volume will be, in this case, V equals volume of cylinder equals pi r squared times height. And the radius in this case is not 14. Our radius is half of 14 because the diameter is 14. So it's 7 centimeters. So our volume of cylinder will be, in this case, pi times 7 squared times 18. Or in this case, let's go to our calculator. I'm going to leave in terms of pi. You know, it makes it easier for us. So we clear all this stuff here. And so we have, in this case, 7 squared times, I think we said was 18. 7 squared times 18, and we get, in this case, 882. 7 squared 18, yes. So we get 882 pi as our 882 pi centimeters cubed. Now, the volume of our I guess, rectangular prism will be length times width times height. And here's the thing, we know what the height's going to be. So this will be, and the length and width are both the same, so we'll call that x. So we'll have x squared times the height of 16 centimeters. So the new container's height is 16 centimeters, so times 16, which will give us 16x squared as our volume, centimeters cubed. And so now to find the base, what we're going to do is to set both volumes equal to each other. So we have 882 pi is equal to 16x squared. So we divide both sides by 16 first. And so x squared is equal to 882 pi divided by 16. We don't want x squared, we want what x is equal to. So we find that the dimension of that side length. So we'll take the square root of both sides. So now to find our x value. So x is equal to, and we want to find the nearest tenth of a centimeter. So I'm underlining these things because a lot of times we sometimes don't see what we're rounding to. We have to be very careful about that. And so we'll take our calculator, and so we'll take the square root. So we'll do second x squared is a square root, and we had in this case 882. So 882 pi, don't forget the pi, divided by 16. Notice it's much easier than having to write out decimals and such. So that's why I left everything in terms of pi first, and then try to solve for x. And we get, in this case, 13.159789844. So round off to the nearest tenth of a centimeter is 13.2 centimeters. So approximately 13.2 centimeters will be the dimension of the base length. Okay, just to make sure, 13.2. Yep, 13.2. Okay, good. All right, so that goes our first part of this null. And so yeah, so if we have our new container, will hold the same number of chocolate covered almonds, and the height of the container is, again, a different shape. It goes from a cylinder to a rectangular prism, and the height goes from 18 centimeters to 16 centimeters, and the diameter was 14 centimeters for the cylinder. Our new square base has to be 13.2 centimeters to kind of give the same exact volume. Same volume in those, so rounded off in this case. Okay, so a store owner sells the chocolate almonds, displays them on a shelf whose dimensions are 80 centimeters long and 60 centimeters wide. Okay, the shelf can only hold one layer of new containers when each new container sits on its square base. Determine and state the maximum number of new containers the store can fit on the shelf. Okay, so if we have in this case, right, so here we go. So it's this shelf here and only one layer. So it says here only one layer. And so this is 80 by 60, 80 centimeters by 60 centimeters. Okay. And determine the maximum number of containers the store can fit. Now, your first thought is going to be to find the area 80 by 60 and then divide by 13.2 squared. Here's the problem. Okay. What you really need to do is to figure out how many times 13.2 will go into 60, and how many times 13.2 will go into 80. Now you're saying, well, why is that the case? Well, unless the owner is okay with overlapping the shelf, which means it might fall off, that's the idea. There will be some loss in between. So here's what we're going to do. So we're going to do 60 divided by 13.2. And that will tell us how many wide we're going to find. Now we can't round up, so here we go, 60 divided by 13.2. So 60 divided by 13.2. And we get 4.5. See, that's the thing, right? So that's a lot. So it's not like you can hang half the container over because it will kind of fall off. Although one might say, well, what if you move it a little bit to the left and right, though? I cannot round up. Okay, assuming in this case that the shelf is, you can't have overlapping, and so the maximum number across, wide in this case would be 4. Okay, and now we're going to do 80 divided by 13.2. Okay, and so here, 80 divided by 13.2. Oops, 13.2. That's 6 and a little bit more. But again, we can only fit 6 whole packages. So about 6. Therefore, the number the store can have is going to be 6 times 4, or 24 boxes on the shelf. Because in this case, we can only go, again, if we break this up, we can only go 6 wide. So here we go. And it'll be left over, right? So 6 wide. Five, 6, and then only 4 deep. Okay, and the overlap will be like here because we had so much here. So here, so each of these spaces, these squares here, will represent where a box can be sitting. And so we would have 6 times 4, or 24. This space here is unusable. I should have used the greens for checks and the reds for X's. So all this space here is unusable because it would go, we would have the box lean over the shelf, which of course would be falling over. So we have to figure out in this case that we can only hold one layer. It'll be 24. If we had done the following, all right, so this is the answer. The answer is going to be 24. Okay, now if we tried to find the other way, basically taking 60 times 80 and then divide by 13.2 squared, we would get 27.5. Notice that you'd have to cut those boxes in half to fit them on the shelf, but you can't do that. That's why in this case, 27.5 or 28 or 27, that's not going to be sufficient though. That would be the incorrect answer because unless the store owner likes to have his boxes kind of hanging over, which might fall onto the ground, which totally wastes the box and all. So that's the thing. So the correct answer is 24. We had to figure out how many times boxes can fit in each dimension first. And then, of course, in this case, use those dimensions to figure out how many boxes can fit in there. All right, ladies and gentlemen, I hope this is helpful, especially, let me get a full page for this, especially for that last question, because in this case, it seems like we just, find one area and divide by a second area, but no, we have to figure out, how many boxes can fit on each one. And so that's a little bit kind of hard to see unless you kind of draw the figure. All right, hope it's helpful. So this is the end of our final exam review 1. I hope you found it helpful for you guys to study from. Notice that you'll have questions similar to this, but also make sure to do final exam part 2, which videos are coming up soon. And in this case, I want to make sure you guys just please leave any questions or comments in the comment section below. Please leave a like for the video. Really appreciate that. And subscribe if you have not done so already. Turn on notifications. Make sure so you know when new videos are added, especially for those who want to get a leg up on Algebra 2, which I'll be doing videos for now that we've completed, kind of come to the end of our geometry section here. All right. Thank you so much for watching. And please, take care of yourselves and be safe.